Welcome back to DeFi Exploits Explained. Today, a vault drained by a single word, unchecked. In June 2026, an attacker turned a few dollars of WETH into a near-infinite token balance and walked off with real assets because one line of guess-optimized math quietly re-enabled the integer overflow bug that Solidity supposedly killed years ago. We'll rebuild the exact mechanism, watch a dust deposit wrapped to a cosmic number, drain the vault on camera, and fix it by deleting one keyword. Let's go. One idea makes this whole hack. Before 2019, Solidity numbers wrapped silently. Subtract 1 from 0 and you didn't get an error. You got the largest number the machine can hold. That caused a wave of overflow hacks. Solidity version 0.8 fixed it. Arithmetic now reverts on overflow or underflow automatically for free, but there's an escape hatch, an unchecked block that turns the safety back off to save a little gas on math. The developer is sure can't overflow. And that's the trap. Put a security critical subtraction inside unchecked, subtract more than you have, and the balance wraps all the way around to nearly 2 to the 256, the 2018 bug back from the dead. And this actually happened. In June 2026, Flooring Protocol, an NFT liquidity platform on Ethereum, lost around $900,000. Its token used a hybrid standard that mixes fungible and non-fungible in one contract over two separate accounting paths. The attacker crafted a fake NFT ID that passed the ownership check in one path but was scored differently in the other, what the researcher who caught it called ghost ownership. That mismatch drove two unchecked underflows, wrapping the attacker's token balance from a dust amount of WETH to near infinite, and they redeemed it against the pools for real assets. Yuga Labs white-hatted 68 NFTs, Bored Apes and CryptoPunks out before the attacker could reach them. The real bug was fancier than we'll build, but the weapon was exactly this, one unchecked subtraction that wrapped. Let's rebuild the core. Here's the core on one screen. Our vault holds 100 WETH for its users. The attacker shows up with 1 WETH of dust and deposits it, so their claim on the vault is 1. Now the trick, they call settle with a fee of 2. 2 is bigger than their credit of 1, and normally 0.8 would revert. But settle does the subtraction inside unchecked. So 1 minus 2 doesn't error, it wraps all the way around to roughly 2 to the 256. Their credit is now astronomically huge, so they call redeem for 101 WETH, the whole vault plus their dollar, the required check waves it through, and the vault pays out everything. $1 of dust drained the entire pool. Let's build it in Foundry. Here's the project, a minimal claim vault, a mock WETH token, and a test that runs the drain and checks the result. Everything runs locally on your machine against no real users and no real money. We start with a skeleton, just a shape, a claim vault that holds a WETH token and tracks each user's credit, their claim on the pool. 3 functions, empty for now, deposit, which takes your WETH and credits you, settle, which adjusts credit by a fee, and redeem, which pays credit back out as WETH. Every function has a comment saying what it does. Now we fill them in the way one keyword makes it deadly. Here's the vault. Deposit is honest. It pulls in your WETH and adds an equal credit. Redeem is honest too. It checks you have enough credit, subtracts it, and sends you the WETH. The whole vulnerability is this one line in settle. It subtracts a fee from your credit, but it wraps that subtraction in an unchecked block. Read it carefully. If the fee is bigger than your credit, 0.8 would normally revert and stop everything. Inside unchecked, it doesn't. It wraps. 1 minus 2 becomes a number with 77 digits. The bug is planted in a single innocent-looking word. Before we run anything, let's read the test. We build the vulnerable vault and seed it with 100 WETH from other users. We give the attacker 1 WETH of dust, then, acting as the attacker, deposit 1, so credit is 1. Settle a fee of 2, that's the underflow. We log the credit so you can see what it becomes. Then redeem 101, the whole vault. The final 2 lines are the claim. The vault's balance is 0 and the attacker's is 101. If that holds, $1 drain the pool. Run it and read the ledger. Step 1, the vault holds 100 WETH from other users. Step 2, the attacker deposits 1, so credit is 1. Step 3, settle 2, and look what credit becomes. A 60-digit number, 1157, and on and on. That's 1 minus 2, wrapped all the way around. Step 4, they redeem 101, and their WETH goes to 101. Step 5, the vault is drained to 0, $1 of dust, 1 unchecked line, the whole pool gone. Passing green means the drain worked exactly as designed. So how do we stop it? I'll delete one word. In settle, we take the subtraction out of the unchecked block, so it's just plain arithmetic again. Now Solidity 0.8's checked math is back in force. Subtract more than you have, and it reverts automatically for free. No wrap, no inflated credit, no drain. The lesson: unchecked is a loaded gun. Only ever point it at math you can mathematically prove won't overflow, never at balances and attacker controls. Same attack now against the fixed vault. The attacker deposits 1, credit is 1, they call settle 2, and this time instead of wrapping, it reverts, arithmetic underflow. The whole call fails, their credit stays 1, and the vault keeps its 101 with 1 deleted keyword, and the drain is impossible. This test passes precisely because the attack now fails. One last proof. This vault isn't only a local test, I deployed it to Sepolia, a real public testnet. Let me read the attacker's credit straight off the chain, live through my own Chainstack node, and there it is. The exact same 77-digit number, the wrapped credit sitting permanently on a public blockchain for anyone to verify. The vault's own WETH balance is now 0, drained, and the attacker walked off with 101. The underflow didn't just happen in a local test, it happened on chain. And this isn't only a local test. I deployed the vault to Sepolia, a real public testnet, and ran the same attack on chain. On top, the vulnerable vault, the redeem transaction succeeds, and the vault is drained right there on the block explorer for anyone to verify. On the bottom, the fixed vault, the exact same settle call reverts on chain. Same code, same attacker. One unchecked, between a robbery and a safe protocol. Quick recap. Since 0.8, Solidity protects you from overflow and underflow for free, but unchecked turns that off. Subtract below 0 inside it, and a tiny balance wraps to an astronomical 1. The fix is usually just removing unchecked from anything an attacker can influence. And in the real flooring bug, the deeper fix was making the two accounting paths a single source of truth, so ownership and balance can never disagree. The rule that runs through all of this, 0.8 saves you, right up until the developer types unchecked and invites the 2018 bug back in. A quick note, rebuilding these hacks safely and explaining them line by line takes real work. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next breakdown. Thank you. That's the unchecked underflow, $1 of dust turned into a near infinite balance by a single missing safety check, rebuilt and fixed in a couple dozen lines. Next episode, the first depositor trick, how the very first person into a vault can quietly set a trap for everyone who deposits after them. Subscribe so you don't miss it, tell me in the comments which exploit to break down next, and I'll see you there.